Today's lesson is going to be to add, subtract, multiply, and rationalize radical expressions. We're going to start by adding and subtracting rational expressions. And what I put in parentheses is what that really means when they put that on the directions is you want to combine like terms. All right, so if we look at number 1, let me get my pen out. On number 1, I have 2 root 7 plus 3 root 7. Since the root 7s are identical, those are actually like terms. And what I'm doing is if my innies, I kind of call these my innies, are the same, I just add them together. So if I have 2 of them plus 3 of them, I'd wind up having 5 root 7. Right? So you combine like terms if the radicals are equal. Same thing with number 2. Now they're asking me to subtract. They say 9 root 5 minus 4 root 5. Well, if I have the equal radicals, then 9 root 5 minus 4 root 5 would just be 5 root 5. If you look at number 3, it says negative 7 times the 4th root of 5 plus 2 times the cube root of 5. Now, if I look to combine those, even though those both have a radical 5, one of these is a 4th root and the other one's a cube root. I cannot combine those because they are not like terms. So this is your final answer because I cannot combine those since they are not like terms. One is a 3rd root and one is a 4th root. If you look at number 4, it doesn't matter what I have within the radical, but as long as what's within the radical is identical, I can combine my like terms. So negative 4 times root xy minus 5 root xy would be negative 9 times root xy. All right. Now number 5 and 6 are going to be more typical to what you'll see. I have a 6 root 18 plus 4 root 8 minus 3 root 72. At this point, I cannot combine anything. The root 18, root 8, and root 72 are not like terms. But what you need to do first is simplify, and then I can see if there's anything that I can combine. So on the side over here, I'm going to say, okay, if I'm taking 18, so I'm going to come over here. If I split up 18, 9 times 2, which is 3 times 3 times 2, I can pull out a 3. And it's going to be 3 root 2. Now you got to be a little careful here. If I have a 6 already here and I'm pulling out a 3. So if I have a 6 offside and I'm pulling out a 3, I multiply those together. So 6 times 3 is 18. Root, I had a 2 left over. Now when I do root 8, if I were to take 8 on the side and break that up, 4 times 2, so 2 times 2 times 2. So I would have 2 root 2. Again, if I'm pulling out a 2, but there's already a 4 there, I have to do 4 times 2. Multiply those two things. So 4 times 2 would be 8. And what was left in my radical was just that little 2. Right? I've got one more thing to break up. Let's break up 72. So if I take 72 and break it up, let's do 9 times 8. So 3 times 3 and 4 times 2, so 2 times 2. So it looks like I have a pair of 2s and a pair of 3s, which means that I would pull out a 6, right? If I'd pull out a 6, but I already have a negative 3, negative 3 times 6 is negative 18, root, what would I have left over? 2. So now if I look, all of those are now root 2s. So since they're like terms, I can combine them. If you look closely, 18 root 2 and negative 18 root 2 will just drop out, so my final answer is 8 root 2. All right, go ahead and try number 6. Press pause in the video and then come on back. I want you to try to simplify those radicals and then combine anything that has like terms. Okay, you should be completed with number 6, and I'll go through number 6 quickly to kind of break it up. Root 50, I'm going to do them over here. If I took 50 and broke that up, 5 times 10, so 5 times 2, you could pull out a 5 and you'd be left with a 2. So I'm going to say 5 root 2 plus, I want to do 32. Since that's not a perfect square, I'm just going to say 8 times 4 is 32. Continue to break this up till you get the prime factorization. It looks like I could pull out a 4. Well, if I could pull out a 4 and I had a 3 there, 4 times 3 would be 12. And who did I have inside? A little root 2. And then if I break up 18, I'm going to go back over here because we already broke up 18. 18 is 3 root 2. So if I have a 3 that comes out and already had a 5 there, 3 times negative 5, excuse me, would give me negative 15 root 2. All right. So again, these wind up having all root 2s as their radicals, which is great because they're like terms. So if you combine these, you'd say 17 root 2 minus 15 root 2, and that answer would be 2 root 2. So when we're asking you to add or subtract radicals, typically you're going to have to simplify and combine. All right, let's look at this second section. Now instead of adding or subtracting, we're going to be multiplying. And really when they say you want to multiply, all I'm going to be doing is foiling, all right? Sometimes you'll be distributing, but if I have a binomial times a binomial, I'm going to FOIL. So just be careful when you do this. Again, you're doing outies with outies, innies with innies, and I'll explain. I'm going to say 3 times 2 is just 6. 3 times 4 root 5. Well, 3 is an outer number and so is 4. I'm going to multiply those. So 3 times 4 is 12. And root 5 times, I don't have anything to multiply by, is just root 5. I'm going to go ahead and do, okay, the inner and the last. 2 root 2 times 2 root 5. 2 times 2 is 4. And just root 5. Now, the last term I have is 2 root 5. I'm going to kind of write it again. Times 4 root 5. Let me redo that. 2 root 5 times 4 root 5. Write it neater. Two root 5 times 4 root 5. Okay, what I'm doing when I'm doing the multiplication of the last terms of these two binomials, 2 times 4, those are outers, would give me 8. Now you got to be careful. Root 5 times root 5 is just 5 because any radical times itself is the number inside. If you think about it, root 5 times root 5 is root 25, and I know the square root of 25 is just 5. So now I'm going to simplify and say, okay, I have 6. These two terms can be combined, and this is really 40. So if I were to combine my constants, 6 plus 40 would be 46. And then 12 root 5 plus 4 root 5 would give me 16 root 5. And that would be my simplified answer for multiplying number 1. All right, let's go ahead and try number 2. So number 2, I'm going to start out by root 8 times 2 root 6. All right, the outer numbers are 2. This is really a 1 here. 2 times 1 would just be 2. 8 times 6 is 48. I'm going to leave that for now, but I'm going to come back, so I'm probably going to be able to break that radical up. I'm going to do my outers. Well, negative 5 times root 8 is negative 5 root 8. If I do my inners, 3 times 2 root 6 is just 6 root 6. And then 3 times negative 5 is minus 15. Now, just be careful. You would lose points. I can't break up root 8. Let's see, because I have 4 times 2. Let's see. Yes, I can. So hold on. Let's break up. Let's do 48 first. Let me put these. Let's do it in green, I guess. Let's start with 48. So 48 is what? 8 times 6, which is 4 times 2. This is 3 times 2. So I have a group of 2's, another group of 2's, and a 3. So 48 would be 4 root 3. Since I already have a 2 out there, and I'm pulling out a 4, 2 times 4 would give me 8. And again, the 3 was what was left inside. Okay. If I take 8 and break that up, it's going to be 2 root 2. So if I pull out a 2 and I have a minus 5, it's going to be a negative 10. Now 6, I can't break that up. I have 3 times 2. What I mean by that is I don't have any pairs that come out. So I'm just going to leave 6 root 6. I'm going to leave minus 15. And that actually is my final answer because I can't combine any further than that. Root 6, root 2, root 3 are different radicals. Since they're not like terms, I can't combine them. And then I'd be done. All right, let's look at number 3. Go ahead and multiply that out. I'm going to have you press pause on the video. Foil those out, foil outies and innies, simplify anything if you can, and then come up with your final answer. Okay, hopefully you're coming back after completing this on your own. You're going to get 8 root 3 minus 3 times 2 is 6, and then root 3 times root 6 would be root 18. Negative 4 times 5 is negative 20. Negative 5, negative 3 would be positive 15 root 6. Right? I know I can't do anything with a 3, but I can break up 18. So if I break up 18, right, it would be 3 root 2. If I break up 18 to be 3 root 2, but I already have a 6 there, 6 times that 3 then would pull out is 18. So I'm going to leave the first term. I had a 6 and pulled out a 3, so that'd be 18, and it's going to be root 2. Can't do anything with the negative 20. Can't simplify any further with the 15 root 6, so there would be my final answer. Okay, so just be really careful when you FOIL with radicals. You want to multiply outies and innies and simplify like terms when you're done. Okay, number 4, why I did this problem is when I have the same binomial written with 1 plus and 1 minus, this is called the conjugate. And we're going to use that in the next section. But I want to show you what happens when you have the same terms, but 1's plus, 1 minus. When I FOIL, what happens and why it's going to be beneficial for us. So let's do this. 7 times 7 is 49. 7 times negative root 3. That's like a negative 1 times 7, so negative 7 root 3. My inner will be a positive 7 root 3. And my last term, negative root 3 times a positive 3. Excuse me. Root 3 times root 3 is 3, but because I have a negative there, it's going to wind up being negative 3. If you look closely, what happens is my inner terms cross out. So when I use a conjugate, I get rid of my radicals, because my final answer would just be 49 minus 3, which would be 46. Right? The reason why the conjugate is so important is I'm going to show you in the next section. You are not allowed to have a radical in the denominator. Right? So what we need to do is we need to figure out on part C, it says rationalize the denominator, and it says use the conjugate. What that means is if I'm not allowed to have a radical in the denominator, I need to multiply by something to get rid of that radical in the denominator. And the way you're going to do that is by multiplying by the conjugate. So if you have 1 minus root 6, the conjugate is the same exact terms, but instead of a minus, I'm going to put a plus. But I can't just multiply the denominator by 1 plus root 6. I'd also have to multiply the numerator by 1 plus root 6 to make sure like I'm multiplying by a fraction of 1, because 1 plus root 6 over 1 plus root 6 is really 1. So what I'm going to do now is once I've decided what to multiply by, once I've determined my conjugate, I'm going to go ahead and multiply the numerator. Well, if I just have 9 times 2 terms, I'm going to distribute. So 9 times 1 is 9. 9 times root 6 would just be 9 root 6. Okay. In the denominator, I have a binomial and a binomial. So I'm going to have to FOIL those two terms. I'm going to have to do what I did in section B, okay, but with more steps. So I'm going to say 1 times 1 is 1. 1 times root 6 is root 6. Negative root 6 times 1 is negative root 6. And negative root 6 times 6 is negative 6. Okay. What will happen if you're doing this correctly is that my radicals in the denominator should drop out. Like this root 6 and this negative root 6 drop out. And I should be able to combine just constants in my denominator. So I'm going to say 9 plus 9 root 6 all over 1 minus 6 is negative 5. And that would be my final answer. If you look now, my fraction does not have any radicals in the denominator. So I did rationalize the denominator and change that fraction to something more appropriate. Okay. I want you to try number 2 on your own. I'm going to help you figure out what the conjugate is, and then I want you to try to FOIL through. So if I have 1 plus root 5, think about what would the conjugate be for 1 plus root 5. 1 minus root 5 is hopefully what you're saying, because it's the same terms but with an opposite sign. All right, so 1 minus root 5 times 1 plus root 5. Let's do the numerator first. Since it's one term times a binomial, I'm just going to distribute. So 2 root 5 times 1 is 2 root 5. Now 2 root 5 times negative root 5, it's negative. 2 times 1 is just 2, but root 5 times root 5 is 5. So I'll come back and change that in a minute. If some of you can look at that and say, oh, it's 2 times 5 is 10, that's great. Put that down. The denominator, 1 times 1 is 1. I'm going to get a negative root 5, a positive root 5, and then a negative root 5 times root 5 is 5. These will cancel. This is going to be 10, so I'll say 2 root 5 minus 10 all over 1 minus 5 is negative 4. Now, because all three of these terms, here, here, and here, are divisible by 2, I'll divide everything by 2 to get my final answer. All right, last question. The only thing that makes this one more difficult is if you look, I still have to use the conjugate because I'm trying to rationalize the denominator. So I should be using, instead of 2 minus root 7, I'm doing 2 plus root 7, numerator and denominator. The difference is the numerator, I also have to FOIL. In the first two problems, I just had to distribute because it was one term. Now I'm going to have to FOIL the numerator, and I'm going to have to FOIL the denominator. So let's do the numerator. 3 times 2 is 6. 3 times root 7 is just 3 root 7. 2 times root 7 is 2 root 7. And then root 7 times root 7 is 7. In the denominator, again, we're FOILing. Make sure you FOIL when you have a binomial times a binomial. 2 times 2 is 4. 2 times root 7 is 2 root 7. Negative 2 times root 7 is negative 2 root 7, and then negative root 7 times 7 is minus 7. Now you're going to be able to see that the ouies, the outer and the inner, are always going to cross out. If you want to do that in your head, that's okay. My only concern is I feel like sometimes when you guys do that, you think the denominator just completely goes away. It's not the entire denominator that goes away, it's just the radicals. So be careful that if you're doing it, you're still doing your first and your last to do the simplification to get it right. So in the numerator, my like terms would be 6 and 7, so that's 13. 3 root 7 and 2 root 7 would be 5 root 7. And then 4 minus 7 will be negative 3. So there's my solution. All right, go ahead and make sure that you guys complete this worksheet, and we'll see you tomorrow to do the work in class.